my friends. This is 9.4. We're going to be working on graphing the quadratic function, they say. Graphing parabolas, and actually we've already done that. The type of parabolas that we graphed before, though, were ones that look like this. Y equals like x squared plus 2. And what we did was we picked points on them. And they told us, be very careful and always pick x is 0. Now, the reason that they're asked us to pick x is 0 is there's an important point on a parabola when you graph it, and that point is called the vertex. And so here's the vertex of this parabola, one that's opening upward, and here's a parabola right here that's opening downward, right? It's going down like this, and this point right here is the vertex. And what they were doing by asking us to do that is guaranteeing that we would pick the vertex by telling us to pick x is 0. But the vertex doesn't always have to happen when x is 0. And so we're going to learn that you need to be able to find the vertex of a parabola. So anything that has x to the second in it, y, you can f of x, you can say this is y, equals, and this is ax to the second plus bx plus c. So anything that looks like this, y equals ax to the second plus bx plus c, where a, b, and c are any real numbers, is going to make a parabola. And that parabola is either going to open upward or it's going to open downward. So either downward like this one or upward like this one. And it will have a vertex. And how you can find that vertex, this is the x-coordinate of the vertex, is given by negative b over 2a. And what a is the coefficient of x squared, and what b is the coefficient of x. And so this right here is actually the x-coordinate of the vertex. And that equals negative b over 2a. I inhaled air. Oh, I can't believe I did that. How you can find the y-coordinate of the vertex is simply by, when you figure out what this number is, by simply plugging in for x. And then you'll be able to find out what y is. And so you just use the equation to find the y-coordinate. And then you can write your vertex as an ordered pair. Now, how you find the x-intercept is you let y equals 0 and solve for x. We did that in chapter 3. And to find I'm going to add that here too, to find the y-intercept, do you guys remember what you do? I'm going to put arrow here. You let, x equals 0 and solve for y. And this is the standard form of a parabola. There's also a vertex form that we haven't met before, but vertex form looks like this. And if it's in vertex form, then the vertex is actually given for free, HK here. You can take this and turn it into vertex form by completing the square. And so if you wanted to, you certainly could do that. They do both in your book, and I'm fine with either one of them. And here how you find the x-intercept is you let y equals 0 and solve for x. So if you have f at x, you can replace it with y when you're letting y equals 0. So anyway, and so we're going to give a try to graphing a parabola here and see how we do. And so this is problem 2 out of your textbook. This is my second take on it because I made an arithmetic on my error on my first take and had to start again. And so because I could not figure it out. What I had, it was like the points are not making a parabola. What am I doing wrong? And I had, yes, an arithmetic mistake. Has that ever happened to you? And so how you find the vertex, right here, I already know that I need more room because I've already been through this before. And how you find the vertex is the formula, the x-coordinate of the vertex is given by negative b over 2a. And here in our parabola, we have that a is 1 and b is negative 2 and c is negative 3, but I don't need to know that to find the x-coordinate of the vertex. So when I plug this in, negative of the what, right? divided by 2 times the what. And let's see, the what is -2 and the what is 1. So I get 2 over 2, which is 1. So the x-coordinate of the vertex is 1. Now if I want to find the y-coordinate of the vertex, all you do is plug in x is 1 into this equation. So this would be what squared minus 2 times the what minus 3, and the what is 1. And when you do the arithmetic there, let's see, that's -5 and 1 is -4. So our vertex is over here at 1, -4. 1, 2, 3, 4. So that's the turning point of our parabola. And now what I'd like to find, they are asking me to find the x-intercept. So I'm going to find the x-intercept. To find the x-intercept, what you do is you let y equals 0. So this is going to be 0 equals x squared minus 2x minus 3. So I'm back in this equation, letting y be 0. And I need to solve that. And that's what we've been practicing solving all of chapter 9. And when it's quadratic, we had 3 methods. We had the square root method, we had the factoring method, and we had the quadratic formula method. There's also completing the square, but I have to admit it's my least favorite method. The square root method would not be appropriate unless I completed the square because of the middle term. So on this one. And then factoring, will it factor? I would much rather factor it than use the quadratic formula, and I'm noticing, yeah, this doesn't have a greatest common factor, and x times x, right, to make the first work because it's a trinomial, and 1 times 3 to make the last work, and when you subtract it you get 2, so I'm like hot diggity dog, it does factor. So let's see, this is going to be x minus 3 times x plus 1 equals 0. So we're getting, for our answers for x, I'm going to have to go up here because of the lack of room, I already know, right? I'm getting x minus 3 equals 0. That's going to be x is 3. And x plus 1 equals 0. That's going to be x equals -1. So those are my x-intercepts. If I want to write them as an ordered pair, I can. The x value is 3. The y value is 0. So x comma y, 3 comma 0. -1, 0. You don't have to write them as ordered pairs though. Our book writes it in shortcut notation, just simply saying the x-intercept is 3 and the x-intercept is -1. I wanted to ask you to find the y-intercept as well, and I know that they didn't ask you to find that, but it's a bonus. So I'll put it right here, y-intercept, and you can look at it as a bonus here. And how you do that, remember, is you let x equals 0. And in the equation, y equals, and when you let x equal 0, it's pretty darn easy. And in fact, the y-intercept is easier than the x-intercept, right? So when the dust clears here, we're going to get y equals -3. So we started with x is 0, and we got y is -3. So 0, -3. So I'm going to plot these 3 additional points onto my grid here. And so I have 0, -3, and I have 3, 1, 2, 1, I'm going the wrong way for 3, 1, 2, 3, and then it won't make a parabola looking thing, and I'll be like, what the heck? And then -1, 0. So I plotted all 3 of those points, and this is my, the vertex is my symmetry, right? And so kind of I'm drawing a little light line in there. And so points should be symmetric on either side of that line. So by symmetry, this point right here should be a point on my parabola as well. If you want to check that that point solves the equation, you certainly can. And that's where I had to start the video over, because I said the ordered pair that goes with this point, I said was 3, -3. So I'm going to be more careful here. It's not. It's really 2, -3, right? So it's really 2, negative 3. So if I plug this in the equation, y equals x squared minus 2x minus 3, so y is negative 3, it ought to be true. And so remember, I'm going to put parentheses here for when I plug in my 2. So 2 here and 2 here. And you can use your calculator or you can use your head, but this is 4, take away 4, which is negative 3, and negative 3 equals negative 3. So that certainly was a good point on this equation, right? And so now I'm going to just kind of sketch in this parabola. As best I can. So this is round here, right? So I've kind of made sure that it was round, and I haven't drawn it looking straight. I've tried to make it rounded. Now they asked the question here, does this parabola open upward or downward? And this one is opening upward. We can look at the graph right there and see that it is opening upward. The other thing that I want you guys to start noticing, and they tell us in the book as well, is that opening upward or downward goes with what A is. If A is positive, if A is positive, it always opens upward. And when A is negative, if A is negative, then it'll open downward. And so that lead term right here tells us if it opens upward or downward, and by being positive or negative. So then they say here that the vertex is at the highest point or the lowest point on the graph. So if we're looking at the vertex right here, are there points that are lower than it? Are there points that are higher than it? And there are no points that are lower than it, so it's the lowest point on the graph. And so always when it's facing upward, then our vertex will be the lowest point on the graph. We're going to try another one. This is problem number 8, and they're asking you the same things on number 8 to find the vertex. And we're going to use that shortcut formula for finding the vertex. The coefficient of x squared, because it's in standard form here, is a. So in this case, a is equal to negative 1. This is c right there. And so here's a right there. And so since b is not there, what do you guys think b is? It must be, b 0. So the x coordinate of the vertex is given by the formula, the shortcut formula, negative b over 2a. And we have negative of 0, right, over 2 times negative 1. And 0 over 2, negative 2, it doesn't matter, right, is 0. So it doesn't matter if I'm saying that the negative divided by a negative is a positive, or if I said that negative 0 is 0, right, because negative 0 is also 0, or how I did that. The sign doesn't matter. This is 0. Now the y-coordinate of the vertex would be given by just plugging in. And so that would be negative of 0 squared plus 1, which is 1. So the vertex is 0, 1, right here. If I wanted to find the x-intercept, that's what they're asking me to find next. The x-intercept, remember what you do, you let y equal 0. So this is going to be 0 equals negative x squared plus 1. And then I go into my, it's quadratic, I want to solve it. And remember, I had these 3 methods. I had the square root method. You can use the square root method when you don't have a middle term, and we didn't have a middle term. And so I could definitely use the square root method if I liked. I could also use factoring on this one, and I could also use the quadratic formula. So all 3 methods work on this one. It's not every problem that has every single method work on it, but on this particular problem, they all will. My favorite method would be the square root method. So I'm going to add x squared to both sides, because what you want to do is you want to get x squared separated from the numbers. So I get x squared equals 1, and I know I'm out of room. X squared equals 1, and now I'm in that, remember, x squared equals k. and I've got them separated there. And so this means that x equals plus or minus the square root of k. That was the even root property. And so this is going to mean that x equals plus or minus the square root of 1, which is mean that x equals plus or minus 1. Okay, so remember that y was 0 and x is 1, or x is negative 1 and y is 0. So written as ordered pairs, that's the x-intercept. The y-intercept, all that room for the x-intercept, right? So all of this room, and I know I had to write small, all of that room is the x-intercept, and the y-intercept is going to be so much nicer, right? So the y-intercept, so here I was finding the x-intercept. You let x equals 0 and plug it into your equation. So y equals negative of 0 squared plus 1. I'm thinking to myself, I think I did that, and I did. Y equals 1. And so the y-intercept, it happens to be the vertex on this one, right? And so that's at 0, 1. And so we already have it plotted. So the x-intercept, negative 1, 0, and 1, 0. And really, that's not enough points to graph a parabola. Like here, I just kind of got enough points just by picking the x-intercept and the y-intercept and the vertex. And so I want to get another few points on there. And so here I am. This is 1. I'm going to pick x is 2, and that just helps to get sketched on the vertex. And I'm going to put it right here. So when x is 2, I'm going to be plugging that in and just doing the arithmetic. So that'll be y equals negative of 2 squared plus 1, which is y equals negative 4 plus 1, y equals negative 3. And so 2, negative 3, 1, 2, 3. And by symmetry, over here at negative 2, there's negative 1. I should have that same point. And if you wanted to go and verify that we do have that same point, we can. So negative 2 in here. And so this was my work to find that one. Y equals negative of this squared plus 1. I'm putting in negative 2. Now, when you square negative 2, I'm going to put my finger over that negative there. That's 4. So this is negative 4 plus 1, which is also negative 3. So we have that. If you wanted to pick 3 and put it in, let's see, that's going to be negative 9, right? Plus, that's going to be 8, negative 8. And so 3 is going to be just a little bit beyond, because that's negative 7. And the same here at negative 3, there's that symmetry. And now I have a lot of points on my parabola, and I can sketch it in. Best of my ability here. Have to erase to make it look just a little bit better, just in case my mother is watching. Something like that, right? Okay. You guys are like, don't get so perfect. And I'm like, okay, oh, that's looking really good. I might put that on the refrigerator here at home. Make sure everyone knows. Now this parabola is opening downward, and I want you to notice that A is negative 1. And remember what we said is that when our A value was negative, that the parabola would be opening downward, and it certainly did. And we found that when it was opening upward, that went with the vertex being the lowest point. And notice that now the vertex is the highest point that goes with this, right? So we did a lovely job on that. So they ask you to graph some parabolas, and there's where I messed up. So these pages are really to go to use the other side. That's what those are for. And now they're asking me to graph this one. And I notice that this parabola is in vertex form. So remember the vertex form? My tea, it's not really coffee. I call it coffee sometimes, even though I do not drink coffee. I hate it just because that's what normal people drink, right? And so just to try to be normal. So my tea is right there. And so when we go to find the vertex, when something's in vertex form, you have to make it look just like this if you want to use it, the vertex form. Now, if you're saying, couldn't I just write this twice and use FOIL, multiply by 2, add the 3, do all of that, and then use that shortcut formula, negative b over 2a. And yes, you would get the same answer. You work a little bit harder, but you would get the same answer. So here is the story, and this really does matter, is that this has to be subtract, and it's not, it's add. So I'm going to rewrite it so that it's a subtract. See how in the formula right here, vertex form, it's a subtract. So y or f of x, that doesn't matter. 2. And then when you write x minus, well, in order to make an plus, this really needs to be negative 1 squared plus 3. Now it's of the form, right? This is our a, this is the x minus, then this thing right here would be our h, right? So now I got it in the form. And so h, which remember the vertex was given by h comma k. So h is negative 1. And then following along, plus, right? And then k, well, k right there is 3. So that's what you would find the vertex is if you did it by the the other method, right? Multiplying it all together. So having it in vertex form actually made it where I don't have to make a note to myself, hey, you need more room. There was the same amount of room there actually, and having it in vertex form was very nice. The one thing though about vertex form there is that that you have to be clever with making it in that x minus h part, and so if they have a plus in there, and so now I want to find the x-intercept, and I realize maybe that's where some of the room went, is here, more room here, and didn't need it, right? So how you find, I'm going to write it up here, and I know I'm more room everywhere on these problems probably need to be a whole page on my notes, and I was trying to save the college money on paper because I'm conservative that way, right? Okay, so how you find the x-intercept is you let y equals 0. So this is going to be, when I do that, I wish I wouldn't have written this in the middle because then I won't have room for the other thing that I want to do. So I'm going to write it over here. So I'm going to let y equals 0. So this is going to look like 0 equals 2 times x plus 1 squared plus 3. And my choice, again, do I FOIL that all out and use, because remember I have my methods of solving quadratic equations. And so do I multiply that all out and try to use factoring or the quadratic formula? But without multiplying it out, I can actually use the square root method because I have something squared and no other variables in the problem. That's when the square root method is really, really good. And so, so I am going to do that. So I'm going to take the 3 to the other side. I'm getting the x plus 1 squared by itself. And I wish I wouldn't be out of room here. That's going to drive me crazy. So I'm going to have to come over here. And I'm sorry, I see your guys' little faces and you guys are going, And then I'm going to divide by 2. So I get that x plus 1 quantity squared equals negative 3 over 2. And now I can use that property, right? That and the big X meant that the X was an expression, x plus 1 squared equals K. And I have a K on the other side, just a number. And this means this is X, that expression equals plus or minus the square root of K. Now, here's what's going to happen here, though, with my plus or minus the square root of k. That's the square root of negative 3 over 2, and that has I in it. And everything that we're graphing here is real. And so this becomes imaginary, and you can actually graph, this is x plus 1 here, you can actually graph this, and you'll learn to graph some complex stuff, I believe, in Math 1. And so anyway, so but it doesn't cross this axis here. Now, if we thought about it, we didn't put our vertex on here. Let's go over here. -1, 3, 1, 2, 3. And we know that because our A value, remember A is 2, A is positive, right? Because it's 2, it opens upward. So if our parabola opens upward, you can see that it's not going to cross the x-axis, right? So this is none. You could also write does not cross. Now I also want to come up with the y-intercept. So the y-intercept. Now how you find the y-intercept is a lot less work. You let x equal 0, and so we're going to have y equals 2 times 0 plus 1 squared plus 3. So we're going to square 1 because 0 plus 1 is 1. So this is going to be 2 times 1 squared plus 3. And of course you can do that with your calculator if you liked. Only 1 is being squared. So that's 1 times 2 plus 3 is 5. So the x-intercept, the y-intercept is 0, 5. The x value was 0, the y value is 5. So if I plot that over 0, 1, 2, 3, 4, 5, and then by symmetry, I know that this point right here is a point on the graph, right, by the symmetry, because this is the vertex, and remember that's the kind of the line of symmetry, cuts my parabola in half. I might want one more point on my parabola just to be sure that it's looking good. So I might pick, and you could pick whatever you wanted, but I might pick 1 is what I might pick. So when I pick 1, and I'm going to put that right in here, so x equals 1, y is going to equal 2 times 1 plus 1 squared plus 3, right? When I do, that's going to be 2, and that's going to be squared. So that's all together here, that's 4 times 2, that's 8 plus 3, that's 11. So y is 11. Wow. Y is at 1, y is 11. This is 7, 8, 9, 10, 11, right? So if I want other values to fall, this one's really skinny parabola. If I want other values to fall on this grid right here, then I'm going to have to pick like half would be something that would maybe fall on the grid, or negative half. I'm going to have to pick some fractions like that, otherwise it gets right off the grid. Okay, we already said that it's opening upward, and that means the vertex is the lowest point on the graph. The reason that I've just asked these two questions here and I know that they didn't ask you that on the out of your book, is because in the next section that's the big thing, and they do it without looking at the parabola, and I want to be able to look at the parabola so that you have that in your mind, and so it's just I know what's coming because I've gone through this book before. Okay. This is problem 14, and so we're going to check it out and see how we do. Here, they're asking us to find the vertex in any 2 convenient points. Right here, when we picked 1, that was a convenient point. So they're not saying that I have to have the x-intercept or the y-intercept. Only pick it if you find it convenient, but do get the vertex. So how you get the vertex is given by, oh my gosh, am I running out of time? Oh my gosh, I have class right now. I'm going to have to do this problem in the next video. Sorry. So